In this video, we're going to be doing strictly refactoring and code cleanup. The goal to be to have a better type safe system, or to better leverage our language TypeScript, and to also create a higher order function that'll allow us to um, create a consistent API for creating routes. Because right now, if I go to uh, the implementation of subscribe handler, we're exposing something that implements or must implement the type for, say, post. So if I were to go to the definition of post, we can see that there's a whole bunch of types that specify what can be added to the second argument of subscribe, or of this method call. So if I close this window and I were to type like this, we're going to get a type error. But we're going to make this a little bit better because this is still error prone. What you see a lot, so something that happens a lot in a larger team, or in a situation where, again, you're rushed or you have a big code base, is that the way that this stuff gets implemented, or these routes get implemented, starts being inconsistent between different routes. So one example might be like status codes, right? So 400 might mean something to one developer in your team, and it might be something else to you, right? So maybe you would have sent 404 for not found, but someone may just send 400, right? So that's one example where you start getting inconsistent HTTP semantics. So we're going to focus on creating a higher order function to handle this. So let's just dive in. I want to see what's going on here. Why is my editor being all strange here? Let me close that. There we go. So the first thing I want to do is I want to demonstrate a situation that we haven't taken into consideration right now. If I try to add Tom at starbucks.com again, so this user already exists in Mailgun, we should get an error. There we go. So we got a 500 internal error. The reason is we're not really handling the situation, and we're sending a catch-all 500. So how are we going to deal with this? The first thing we're going to do is we're going to create some utilities for our email module to handle errors. And also we're going to specify sort of like a type that represents all the possibilities that could occur with Mailgun. So let's do that. I'm in my file tree here, and I'm going to add a new module called email-utils.ts. I'm going to go in here, and the first thing I want to export is that type I was just mentioning. So I want a type that represents all the things that could ever occur with Mailgun. So the way I'm going to do that is by using a enum, email API outcome, and I'm going to have one value here for success, conflict, and unknown error. Okay, so this catches all the different situations that I know so far, or that we're going to deal with, and that allows us to encode all the possibilities of Mailgun into our type system. Okay. The next thing I want to do is use that type here. So what I want to do is, instead of returning nothing, I want to be able to return that information to the consumer of this function. So I'm going to import from email utils, okay, outcome, and I'm going to go here. Let me close this. There we go. So I'm returning email API outcome. And so now we're starting to get type errors because we're not returning what TypeScript expects. So let's do that here. Again, remember that Axios, so the reason we returned a 500 is because we called this function, and when we called it, Axios threw an exception. The reason Axios threw an exception was because it received a HTTP status code from Mailgun that was something other than a 2XX status code. So, 3 something, 4 something, or 5 something from Mailgun, they all get jumbled into an exception by Axios. It's something like this. Like the object is called something like Axios exception or Axios error. So we'll handle that momentarily. But for now, now we've appeased the compiler. But I want to show you something. I want to talk about a interesting fact about TypeScript and about exceptions in general. So one thing that you may have inferred from what I was just saying is that you're able to throw exceptions and the compiler isn't going to be able to help you in that regard. Like, what would be an example? If I do throw new exception, or sorry, error, throw new error. Oh no. And if I do if 1 plus 1, just so that the compiler doesn't complain here. Okay. So the compiler has no idea right now that this function could throw. Okay. So this, if I were to maybe go into my route handler and I were to hover over here, if I read here, I see, oh, this function, add subscriber to mailing list, takes an argument and it does something asynchronous and then it returns an outcome. But nowhere in the type system does it say that this function could fail. That's why it's typical to use a .catch, but oftentimes people forget to catch exceptions. So something that I like to do is to turn these asynchronous functions into pure functions that never throw. And if they do throw, that's okay still. Like if for some reason something starts throwing, then something has occurred that my system didn't account for. And because my system didn't account for that, I can then read the logs, be alerted, and update my system to, in the future, account for those things. But to have a naive catch statement that catches every single error that could ever happen, but you not know what that error is, isn't very helpful. So, with that said, I want a way to prevent this function from throwing exceptions and from always just returning an email API outcome and therefore becoming a pure function in that sense. So what I'm going to do is I'm going to wrap this actually. Try catch e here. So I'm going to wrap this in a try catch, and instead of throwing any sort of exception, I'm going to return something. So now this function will always return a consistent value. So for right now, I can just throw an unknown error. And here, I can return a email API outcome success like I was before. So in general, this approach is something you see a lot in pure functional languages where you don't use exceptions to deal with errors, you use types to deal with errors. So again, I just created a type that makes sense for me. That's very simple right now, but in the future, this type could be a lot more complex and could contain a ton of data about all the different circumstances. So there could be data for success, different data for conflict, and different data for unknown errors. What else? So I'll also show what other benefits this has in a moment beyond just philosophical ones. So let's continue here. The other nice thing is that it cleans up your code. So now you no longer need to do a catch here. this isn't going to throw, so you can await it. Oh, here. Let's just do dot then syntax for now here. Outcome. And here I can do if outcome equals equals. Let me see here. Oh, whoops. Utiles. Oh, whoopsies. I think I might actually move this into email or re-export it. Email API outcome dot success. Whoops. So here we go. Else if outcome. You know what? For now, we're just going to have a simple. So the functionality hasn't changed yet, except now you don't have to have a catch statement here, and don't have to concern yourself with this function throwing exceptions. Okay, so where are we? Okay, so we're going to go to email utils, and we're going to start dealing with Axios and helping us extrapolate the errors from this E error from Axios. Let's do Axios error here. Well, actually, I'm not going to call it Axios error because you don't yet know if it is indeed an Axios error. So remember, Axios is an NPM module that also has dependencies. So maybe one of Axios's dependencies is failing. So you can't really ascertain yet that this is indeed a Axios error. And in fact, newer versions of TypeScript have a implicit type here of unknown. But because we're using, I believe, TypeScript 3, so if I go to TypeScript, yeah, 3.8, that's not yet in the compiler features. But moving forward, this is going to be an unknown, and you never know what this could be, because there's so many layers of dependencies that could all throw. So you have to do your own validation of the error in order to what's it called? In order to ascertain that it's an Axios error. So let's do that. I'm going to implement a function called into email API outcome that takes an error. Yeah. So this function is going to be a utility function for error handling. It's going to take an error, which again is going to be of type unknown, which is conceptually the same as any, but type safe. And it's going to adhere to the type that we've specified here on line 9, email API outcome. So for the sake of, well, I don't know what to call this, but I'm just going to import this function that's not yet implemented. And then I'm going to go into email utils and begin implementing it. So like I mentioned, this is going to be a function that takes a single value, which we don't yet know what it is. But regardless of what it is, it's always going to return an email API outcome regardless. Okay. And now it's a matter of narrowing down that type. So if you think about an unknown, again, conceptually the same as any. So any represents all the possible things in the universe in a value, right? So like this argument on line 9 could literally be anything at this point. So it's our goal to narrow that down. And the way I'm going to do that is I'm going to be doing a similar approach as to what we did with our amp.ts project, or sorry, file, which is I'm informing the compiler through validation of what a value could be. Now keep in mind that this does get a little tedious, and there are libraries out there that do this for you. So one example is Zod. I believe this is it. So it's a schema validation library that also gives you types at compile time. I don't want to use this because it might get a little overwhelming, and I rather show you sort of from first principles what those libraries are doing under the hood. So in any case, if I go into here, yeah, we need to first see, is this thing an Axios error? So we're going to do if is Axios error. We're going to pass in the error. We're going to return, I see, okay. I'm just looking at my notes and I'm trying to remember what I did. So Axios, when Axios comes back with an HTTP response, we can maybe log it actually. I wonder where that would live. Yeah, let's do this for now. Okay, there we go. So I just want to demonstrate the shape of the Axios error. And I need to fix one last thing. So I need to save here. Now I'm getting no issues. I'm going to go into local. We should get a 500. And now the logs will show us what I'm trying to do. So Axios comes back with a ton of information when an exception is thrown. But the most important thing is this top level field called is Axios error. So that's the thing I'm going to use to tell TypeScript if something is indeed an Axios error or not. So if I do a function here, const is Axios error, takes a error unknown and error is Axios error, which I think, there we go. Yeah, so there is a type called Axios error. I wasn't wrong. Okay. So this function is going to take a single argument and return a Boolean. And what we're going to do is we're going to say, we're going to use that same isObject function that we were using for our validation. So rather than re-implement that function, I'm going to create a utilities file. So I'm going to say utils.ts, and I'm going to copy, where is it? IsValidConfig, and go here. Whoa, that's not what I meant to do. Let's try that again. Whoops. There we go. Okay. So what I want to do is I want to say, I don't know if I'm going to export this type, but what I'm going to do is I'm going to create a more generic type name. So I'm going to say obj. So with the validation on line 7, what we can ascertain at this point is that the value has this type. And so I'm going to say value is obj. Okay, is valid config. I'm also going to rename this to isObject. And I'm going to go here and import is, well, let me reference the module first. So now I can do isObject. And there we go. I can close this and this. and I can import this from utils. Okay, and there we go. So I can do is object err. All right, and because this function returns a Boolean, I'm basically overriding the type. So isObject says that the value is a record of string unknown, and here, oh, actually, sorry, there is one more thing I need to do, because otherwise I would not be telling the truth to the compiler. So I have to say dot is Axios error. Okay, and this needs to be casted to a Boolean. So I'm just using the double bang exclamation mark thing to cast this value to a Boolean, even though it already is technically. Let me see. Where is it? Yeah, we keep recompiling and the emulator doesn't like that. Yeah, so the value is called is Axios error. So let me just make sure. There we go. Okay, so this function is going to tell us at compile time if we have an Axios error or not. So let me do error is Axios error and pass in that error object. And let me just show you something really quickly. So if I assign a value here from error, this is currently unknown. But inside here, this is Axios error. So that's the magic of these validation rules. This allows me to access values in an Axios error in a safe way. Whereas here, you're not allowed to. I can't be like test.response. That's just not allowed. Yeah. Okay. So what do we do? Now that we have an Axios error here, I want to get the HTTP status code. And that's going to tell us if we have a conflict or not, which is what we're having right now when we send this request to our own server. So I'm going to do error, question mark, question mark, response, question mark, period, status, equals 404. Okay. Here I can say return email API outcome dot not found or conflict. Yeah. Okay. Otherwise, we don't know what's going on. So this is an unanticipated error from Axios. So here we can say console dot error unknown Axios error for email API, and we can log this out. And let's close the quotes. There we go. Hey there, it's getting a little late, and I realized that I used a 404, which means not found for conflict. So I'm going to sort of go back in time and continue where we left off. So I'm going to change that to a 400, and let's see here. I'm going to regain my train of thought. So the other thing that we have here is we have unknown errors right now. So let's have a return for unknown errors here, except these are Axios errors. So I'm going to do console.error. I'm going to use the backticks, and I'm going to say unknown Axios error for email API, and then I'm going to simply log out this error. Okay. And here, similar error logging. Let's do this, although the wording is going to be a little bit different. It's going to be unknown email API error. Yeah. So at this point, we know at least that it's not an Axios issue. or it was something, beneath Axios, or yeah, we just don't know. Email API issue. So in these situations where you have these unknown errors, something that would be more realistic, let me quickly fix this. Something that would be more realistic at this point would be to have some sort of logging. So if you have like Stackdriver for GCP, or if you're using something like Sentry, here you would ring the alarm and say something's not happening or not going right here. Something's not going good. Let me just check my compiler output. So that looks good. I also want to see if, go to routes, subscribe. There we go. So I've also updated the endpoint here to handle the different circumstances. So conflict, also not a 4.4. This is a, what is it, 409? My mind is a little foggy right now. HTTP statuses, let me just confirm, 409, conflict. Okay, so we have success, conflict, and we don't know what's happening. So if all things are good, let's try it out. There we go. Now we're getting 409s. Let's see here. So that's a slightly better improvement. So now we have a controlled way, at least, of dealing with Axios. So if I go to email, yeah, oh, I guess I was already there. Yeah, if I go to here, we can see that Axios is sort of in a contained box. We have this third-party package that we've sort of like wielded now, and can't sort of wreak havoc in our system now. So let's continue with improving our types and the type safety of our application, and overall just making it more modular. So we're going to create a function called createHandler. So this is going to be a useful function, especially if imagine you're working with a team and you're trying to make routes quickly and consistently. This function would be sort of this higher order function that takes a handler. So let's dive into that, and we'll see the benefits of that in a moment. Let me pull up my notes. Yeah, and I guess the other thing I didn't mention is that we want mistakes to be as hard to make. Ideally, mistakes can be completely eliminated at compile time. Uh, you know, if, for example, you can prevent this function from ever throwing, then that's one mistake that you could avoid because someone may have forgotten to do a dot catch or something. Yeah. So I'm going to create a new file, and I'm going to call it router. Okay. And I'm going to export a function. Okay. This function is going to take a function. So before I get into all the details, I want to kind of take a second to talk about what we're trying to build. So we have an HTTP server that has a known set of outcomes. The server could totally fail, or it could be in a failed state. So like a request come in and something could go wrong, and so the request failed. There's succeeded. There's also a not found. So like a route could be not found, or more specifically in our case, a user could be not found. So for example, if you're trying to unsubscribe, which we'll do in a subsequent video, if you're trying to unsubscribe and your email doesn't exist, then the server's going to return not found. And then there's conflicts. So we've already demonstrated conflicts here. Okay, so those are the known set of things that could occur in our system. So let's create a type to model that. I'm just going to call it handler result, and I'm going to use string literals to model model these outcomes. Although an enum could work just as well. I'm gonna choose to use a string literal. By the way, this is called an algebraic data type. I don't want to go into the details, but you'll see in a moment how I use them. And throughout this video series, you'll see more and more examples of algebraic data types to be used to decide what to do or handle errors, for example. One thing to keep in mind is that because we're using string literals as types, the values are technically not strings. So let me show you an example. Const result is of type handler result. So let's do that. If I do, let me see, is this gonna work? This is gonna work. Okay, cool. So the compiler here has inferred that this is of type. So the type of this is not string. It's literally this. Okay, so this is valid TypeScript syntax, and it's saying that this value is of this type. Okay, you'll see some examples as I code where you can't simply, assign a string to a type like this. That in that situation did work. I was a little surprised by that. So let's see. One of the things we need to do. So like we have sort of like the different states modeled in our system. But we also want to talk about what are like the steps our server is going to take. So in our particular case, we're always going to have, so we're going to let's think about 3 endpoints that we're going to have. We're going to have a subscribe endpoint, a unsubscribe endpoint, and we're going to have a send newsletter endpoint. Every single one of these endpoints are going to take data. So like the server is going to expect data for every single one of those. And that data needs to conform to something that's specific for that route. So for example, for the subscribe endpoint and the unsubscribe endpoint, you're going to expect a object that has an email field in it, and the value needs to be an actual email. For your send newsletter endpoint, that's going to take some other kind of data, and it needs to be valid data in accordance to that endpoint, right? So if I were to think about that in terms of my types, I'd have something like this. I would have something called validator. Type validator takes a type T, and it's going to be, maybe I can close this. There we go. It's going to take a request body. Let's see. Do I want to say? I want to say that this is going to be a record. Okay. And then it's going to return T or null. Okay. One thing I want to change with this type is move the type argument to this side of the function declaration. No, that's not right. Okay. So this is a mouthful potentially, but what this represents is a function that takes some JavaScript object with unknown data inside it. Okay, so all the keys in a JavaScript object are strings. So that's why I'm using string as the key value. But we haven't yet validated the values of those keys. And what I'm saying here at the end is that this function is either going to return some data of some shape. We don't want to enforce the shape of the data. That's up to the implementer of this interface. So the implementation, anytime you call create route, is going to return some data of type T. If it's valid, if it's not valid, it's going to return null. Okay, so let me show you why that is in a moment. The other thing is, so let's say that we call our validator with request body, and then we get some data, right? Okay. So if you get some data, you want to do something with that data. Okay. So I want to create a handler that takes this data and does something with it. So I'm going to do type handler that takes our type argument, takes our data of type t, and does something asynchronous with that data, which is why I'm providing a promise. And we're going to return our handler result. Okay? So these two types in combination provide us with a sort of model, a conceptual model of what our server does. It's going to take some data, validate it, and then do something with it, and then it's going to either fail, succeed, not find something, or have a conflict. Okay. The other thing I want to do is I want to bring these together. Okay. So I'm going to create my create route function here. So I'm going to have a type argument of type t. I'm going to have my validator, and it's going to pass in this type t. And then I'm going to have a second argument called my handler, or it is my handler. Okay. And this function, this function is going to return a express handler. Okay. There we go. Oh, whoopsies. Request. Okay. So we've created a higher order function that's going to allow us to abstract away the need to send HTTP statuses, and again to like not make mistakes. So I don't know if you remember in one of my first videos, or the first video where I introduced Express, I forgot to send a status, right? I didn't call res.send status 200 in that video. That was a mistake. And what we're going to do is, by having this create route higher order function, we're going to abstract that away and prevent people from forgetting, for example, to send a HTTP status code. So let's see here. What I want to do is, let's see here, validation result. So I'm going to go ahead and implement this. And what I'm going to do is I'm going to do validator rec.body. Okay. So that's the first step. The first step is to take the request body from the request, pass it our validator, and let me hover over this. See that? I have that type from here. So if the data was processed correctly, I think a better name for validator might be deserializer, maybe, but I won't obsess over the names. And what I can do now is I can say if, let me fix the formatting here. So if there is no outcome, we can say, or sorry, no data, then we're going to say that the validation failed. And we're going to say res.send status 400 for a bad request. So the request that came in, the data didn't adhere to the requirements of that specific route, and therefore we're going to send a 400. It's a bad request. Next up is the actual handler. So here I'm going to await the handler with validation result. So if I hover over this, remember at this point it's a T or null, but, oh, there we go. But at this point, it's a type T. Okay, so we've narrowed down the type because of this check. And if I were to remove this, I will get a compiler error. All right, so we're leveraging the type system here to help us avoid issues or errors and surprises. So the next thing is we create a handler result. And here, I can return a HTTP status code. So here I can do const code is equal to, I'm going to think about this in a second. Just give me 1 sec. Return. I don't think I need a return actually here. Is my formatting incorrect again? No, it's fine. Res.send status code. Okay. So given this data type handler result, I'm gonna return a numeric value. So a simple way to do this for just off the top of my head, well, it's not really off the top of my head. I have notes in front of me, but yeah, so this is gonna work. But you can definitely improve on this design. I'm gonna have a hash map. Okay, so here the keys are gonna be the results, conflict 409. So now I don't really need to think about these status codes anymore. Okay, and I want to show you something in a second once I finish this. Whoops. HTTP status code map. I'm going to key into that with a handler result. There we go. Okay, so something I want to show you is, let's suppose our server gets more complex and we have another outcome that could occur here. Let's see, not found, conflict, succeeded, failed. What's something that could occur in the future if this were to get more complex? Oh, yeah, unauthorized. So let's think about unauthorized here. Actually, we won't do unauthorized because there is going to be a different mechanism for that. But let's say, let's just pick a random one, locked. Okay. You could have your also your custom error code, right? So like you could have a company specific or team specific error that doesn't make sense in the context of the HTTP spec, but you can map it to an HTTP error. My custom company code like error, like not enough unicorns. Okay, so if your system doesn't have enough unicorns, if you add that, so let's say you're a developer and you're working on this, the second you add that value into the set of possible values that your server could be in, or could, the handler could return, you're going to get a compiler error, and you're going to be forced to like handle that. So right now you have a very self-contained error, but in a code base that's a bit bigger, you can follow the compiler errors, fix them, and then suddenly, boom, you've taken into consideration that new addition in your types. So that's why it's nice to always start a feature with your types first, and then have the compiler tell you basically when you're done. Obviously, tests are important, but I'm talking about in the context of like how to work with a compiler or how to work in a statically typed language. So I'm going to remove that. And the next thing is I need to refactor my function for subscribing. So let's see here. Right, so The other thing we want to do now is take advantage of this create handler function. Okay, so I'm going to import, let's see, or create route. Is that what I called it? Sure. You know what? Yeah, it's fine. I was gonna call it something else, but create route also makes sense. So let me comment this out for now, and let's start from scratch here. So export default, create route, and we're gonna take a validator. Okay. I'm gonna define it here. Let's see. So we need a validator that takes some data and returns an email. Okay, so let's see here. Const email validator is equal is equal to something here like take request body and returns a string. Okay. The other thing I want is to export this validator type. Okay. So now I can do this. So this variable is a validator that returns a string. And now I can omit the types from the function. And the function will be required to implement the interface of this email validator type. Okay, so we're going to take a request body and we're going to do something with it. So what I want to do is do type of request body dot email equals 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 string and yeah, validator dot is email request body dot email. Okay, something else I could do is I could destructure here email, and here we can condense our code a little bit. Okay, so if that's the case, we're going to return, well, what do you think I'm going to return? I'm going to return an email. And if this validation fails, so I return null. Okay, so let me go back to the type definition. Remember, this takes a single argument, which is a object with string keys and whose values are either unknown or not defined at all. And we're going to return some type t, which in our case is a string, or we're going to return nothing if the value isn't valid, right? So that's what I'm doing. Type of, there we go. So if the type of the email field is a string and it is indeed a valid email, let's return the email, otherwise return nothing. Okay, so let's pass that in here, email validator. And the next thing is we're actually going to have access to our email. And now I can lowercase the email. Let's say, the way I'll do this is I'll copy this. Whoops. Email to lowercase. Okay. I'm also going to make this async. Const outcome equals 08. Let's see. And now we need to map this outcome to a route result. Is that what it's called? Handler result. Okay, so the way I'm going to do that is basically similar idea here. Email API outcome dot success. return succeeded. Here we can finish off by doing that for now. Okay, so we've refactored this and we're still getting an error. Let's go to the top here, remove this. Okay, so we've cleaned up this a little bit, but we're still returning we still have a bit of boilerplate here. Okay, maybe there might be a way to convert this type. Okay, maybe there's a way to convert this type into a handler result. So what I'm going to do is inside my utils file, I'm going to bring those two types together into a function. So I'm going to do const into handler result. I'm going to take an outcome, email API outcome. We're going to auto import that handler result, and there we go. Why did that not get imported? Oh, it's not capitalized. Oh, I haven't exported it, that's why. So this is inside router. Export, there we go. Let's go back to utils. Okay, and what I'm going to do here is I'm going to use a switch statement. Okay, I'm going to say case email API outcome dot success return succeeded case email API outcome conflict return conflict case email API outcome unknown error return failed. Okay, now something you should know, let's see here, import from router. Okay, something you should know is with this pattern, there is, yes, there is a bit of boilerplate, but this function is also an interesting type-safe approach to expanding the possibilities of, say, for example, email API outcome. So if I go to this type and I say something else, if I add that value and I go over to utils, we're going to have a type error now. Okay, so what I'm trying to demonstrate is that when you combine these types together, you start getting help from the compiler, and the compiler says, hey, you added this new feature. By the way, you forgot to deal with that feature in this file. Okay. The reason that this works, by the way, is because I don't have a default. So in a switch statement in JavaScript, there is a default branch where you can do stuff. I intentionally omit the default value because then that allows the compiler to assess whether I've exhausted all the different possibilities of this email outcome type. Okay, so I'm going to remove it, and by removing it, the error is gone. So that is that. Oh, and let's use it. Okay, so let's go to our route. Let's go to our subscribe route. So now we can get rid of this boilerplate. Now we can really simplify this. I can go here and how do I want to do this? I want to remove all this. Okay. I also don't need this anymore. And I can remove that. I can make it implicitly return. And I can do a dot then into handler result. Boom. And there we are. So our function has been trimmed down. Let's see. Oh, whoopsies. There we go. So our function has been condensed down to the essentials. Okay. Is there anything else I'm missing? So let's test it out one last time locally. I should still get a 404 or 409. My apologies. And if I add a new value, so let's do, I'm going to use my Twitch username, vimboycolor at twitch.com. I should get an OK. There we go. So the other thing I want to do is deploy, which you already know how to do. So I'm actually going to omit that from this video, but if you want to do that, it'd be npm run deploy if you're following along. And that's it for this video. In the next video, I'm going to talk about the creation of the unsubscribe endpoint. Till next time.